Okay, today we're going to be talking about series and sequences. And so the first thing that you need to know is that any certain term of a sequence is called a sub n. And in this section, it's really important to read directions carefully. How many terms am I supposed to write out in example 1a?
Four.
4. So if you can't read, that's kind of an issue. 4 terms. Now, when we talk about things, usually we say things like, hey, I want the first thing. And what we would say about that is that's a sub 1. If I want the 7th thing, we would call that a sub 7. So whenever you're talking about these things, the number that they're talking about, the cardinal number, the 7th, the 8th, the 25th, that's the number that's going in for n. It's a counting tool to talk about which term you're talking about. So in example number 1a, what they're saying is, if I wanted the first term, or in other words, if I wanted a sub 1, that would be 2 times 1 plus 5, or in other words, 7. If I wanted a sub 2, that would be 2 times 2 plus 5, or in other words, 9. A sub 3, 2 times 3 plus 5, so that's 11. And a sub 4 would be 2 times 4 plus 5, or in other words, 13. And hopefully you notice, as you're looking, that each of these numbers are the numbers that I'm plugging in. Okay, and so part B works exactly the same as part A. And the numbers that I'm plugging in are each of those numbers, the first, the second, the third, the fourth, which means the numbers 1, 2, 3, and 4. And so you can see in the yellow highlight all those numbers that were being plugged in. So my first 4 terms would be negative 1/2, positive 1/5, negative 1/10, and positive 1/17. Questions on A or B? In number 2, we're going to go backwards this time. We are actually going to create the a sub n term. And so it's kind of helpful to see what's going on before you do that. What I notice is going from 1 to 5 is a jump of 4 units. 5 to 9 is a jump of 4 units. 9 to 13 is a jump of 4 units. And every single time, I'm adding 4. So the way that I start out when I see that is I start out with my a sub n equals 4n. Whatever you're adding each time or subtracting, that goes in front of the n. So if I would have been subtracting 7 each time, minus 7n would be the way I started. Now if I'm looking at that first term, the number is 1. So if I plug in the number 1 for my first term in for the n, what I should see come out is a 1 in the end. But that doesn't work, because if I plug in a 1 for the n, meaning my first term, I end up with a 4. So I have to adjust my equation by subtracting off 3. And now what I see is if I were to plug in whichever term it is, for example, let's say that I was looking for the 1, 2, 3, 4, 5th term. That means where I see the n, I would plug in a 5. 4 times 5 is 20, minus 3, 17. In part B, you notice something kind of strange right away when you do this problem. Going from 3 to 6, I'm jumping by 3, but from 6 to 11, I'm jumping by 5. And then from 11 to 18, I'm jumping by 7. And then 18 to 27, I'm jumping by 9. That causes a small issue. But what I do notice is if I go one more level, 3 to 5, I'm jumping by 2. 5 to 7, I'm jumping by 2. 7 to 9, I'm jumping by 2. When you see something like this occurring, what this is indicating is that you have a quadratic expression, meaning a squared. So that means that my a sub n will be n squared to start with. So instead of having something times the n, it's n times the n. And then just like in the previous one in letter A, we're going to adjust. So I look at this and I go, okay, the first number I plug in, a sub 1, means I put a 1 in for the n. 1 squared is 1, but I wanted to see a 3, so I adjust. And I add 2. So if I want the fifth term, the fifth one, 5 squared is 25 plus 2, and I see the 27. Aha! And now to Tristan's question. Recursion. How many terms am I supposed to be writing?
4.
Good reading, Joe. So I'm going to do the first 4 terms. If I do the first 4 terms, oh look, they even give me a sub 1. It's 4, because they said so. This a sub n plus 1 equals a sub n is saying that each next term, this is standing for the word next, and this is standing for the word now. So to get the next term, take whatever you've got right now and subtract off 8. So a sub 2 is going to be 4 minus 8. Or in other words, negative 4. This thing right here, minus 8, is occurring right there. The 4 was because that's what you needed to start with to get to the next number. If I want the third term, Joe, please stop. I take the current one that I have. What's the current number? Negative 4. And what do I do to it? Subtract 8. So now I'm at negative 12. Again, this minus 8 is what I'm doing to the current number. Now my current number is negative 12. So a sub 4 will be equal to negative 12 minus 8, or in other words, negative 20. Again, all we're doing is subtracting 8 each time. So now I have my 4 numbers. 4, negative 12, negative 20. Alright, in letter B, same kind of deal. The good news is they tell us right away what our first term is. So a sub 1 is negative 1. To get to a sub 2 then, I take my previous term, which was negative 1, and I square it and add 1. So that'd be 1 plus 1, or in other words, 2. A sub 3 then would be the previous number, which is positive 2, squared, plus 1, or in other words, 5. And then the last term, a sub 4, would be the previous number, 5, squared plus 1, or in other words, 26. What you can see is in every subsequent number, I'm plugging in what we had before to get the next number. That's called recursion. So when you take your test, when it comes up, it's going to be really important to understand if they use the word recursion, this is the process in number 3 that we're going to be using. If not, it's from once before. Next, we're going to be talking about factorial. And the big idea behind factorial is whatever number you see, you keep multiplying until you get to 1. So 0 factorial, believe it or not, strangely enough, don't really know. 1. I'm putting in a nice highlighter. It's 1. 1, in case you didn't get it the first time.
Looks like
1 factorial is 1 times 1, which is 1. 2 factorial is 2 times 1, which is 2. 3 factorial is 3 times 2 times 1, which is 6. 4 factorial is 4 times 3 times 2 times 1, which is 24. 5 factorial, this is fun, isn't it? Is 5 times 4 times 3 times 2 times 1, which is 120. Thank you. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, which is 720. And 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. And Rice, that is?
5,040. 5,040.
Thank you. 5,040.
I'm trying to give this girl credit.
Let's try it now. How many terms are we going to write?
First four.
4. A sub 1 is going to be 1 squared over 1 factorial, which is 1 over 1, 1. A sub 2 is going to be 2 squared over 2 factorial, or in other words, 4 over 2, which is 2. A sub 3 is going to be 3 squared over 3 factorial, which is the same thing as 9 over 6, which is 3 halves. And then the last one, a sub 4 is equal to 4 squared all over 4 factorial, which is 16 over 24, which is the same as 2/3. Now, all of these sequences, like for example this very last one, if I wanted to, as a final answer, what I could have done, and if you prefer, you're more than welcome to write it as 1, comma, 2, comma, 3 halves, comma, 2/3. So if you like to write your 4 terms that way, that's fine. It doesn't say to write it that way, so the 4 terms, if you write them out the way we just got done with, that's fine as well. In number 6, what we notice is we have a bunch of factorials, and